All right, so we're on our last section of Chapter 8, which is going to be Section 8.7, covering Dalton's law of partial pressure. Effectively, what Dalton's law says is that the total pressure of a system is just due to the individual pressures of each gas. So there's a pressure associated with the oxygen, a pressure associated with helium. If I add those two pressures up, I'll get the total pressure of the system. So the problem says a scuba tank contains oxygen gas with a pressure of 0.450 atmosphere. So this is my PO2. So we're going to have to start using subscripts instead of numbers. We can also use other indicators. So in this case, I just call it PO2 for the partial pressure of oxygen. It also says helium gas is also in that scuba tank, and its partial pressure of helium is going to be 855 millimeters of mercury, right? It sounds unusual, but helium is used in scuba tanks, right? So it's asking us to find what is the total pressure of this, under these conditions, of this scuba tank if I have these pressures for helium and for oxygen. So using Dalton's law, I know P total, which I'm being asked to find, is just adding the pressures up. The only trick or catch to this problem are my units don't agree. So the only way you can add units is that you have to agree. Luckily, the problem has told us that we should be solving for millimeters of mercury. So we're good with the helium. Our first step is going to be converting oxygen in the units of atmosphere to units of millimeters of mercury. So let's do that first. We'll start with what we're given. So we know it's 0.450 ATM. I'm going to need a conversion factor to get me to millimeters of mercury. That conversion factor is going to be 1 atmosphere is equal to 760 millimeters of mercury. If I do that math out, what I'll end up with is 342, and I'm running out of space on the board, I think. Oh, I can fit it. Millimeters of mercury. So take a look here. There's my PO2. There's my PHE. I'm good to add them together. So my P total, my PO, or O2, is my oxygen, so 352 millimeters of mercury. I can add that now to my partial pressure of helium, which is 855 millimeters of mercury. P total is going to be equal to, I have 1.20 times 10 to the third, so that's going to be 1,200 millimeters of mercury. That sounds like a lot of pressure. It's because it is. All right, and that is our representative problem for Dalton's law.